Hi, Bernard.
Hi,
This
Carsten.
is our third video series. So this is maybe the time to give us a, how you said, a sound.
Yeah, we want to celebrate something?
Yeah, we want to celebrate.
Okay. No, hello everyone. We thought that this topic might be a good one in order to get some information out to you folks because it has been widely discussed, and there will probably some news to it in the future.
Yeah.
But I think for the current state, which is September 2023, um, we'll do a series about Azure Stack HCI in a stretch cluster scenario.
Yeah, and we will include our other series because we did already an Azure Stack HCI installation series with a non-stretch cluster. So we will
Right.
not redo everything we have to do. Of course, you have to install the nodes, you have to domain join them, and so on. We
Mhm.
will include only the parts that are separate or different in a stretch cluster scenario,
Yeah.
and we will refer to the other series. So,
Yeah. So I think
Bernard.
for most of the people, I mean, it's a valid discussion when they would ever consider a stretch cluster scenario. So I think before we dive into the technical stuff and really do the implementation, bear with us. We need to talk a little bit about some concepts here and why we would ever use or recommend to use a stretch cluster. So maybe
I have a
Carsten, you take.
question, Bernard.
Mhm.
Who are we?
Yes. So my name is Bernard Frank. I'm working for Microsoft. So I'm a little bit biased here. If you watch this, I'm a fan of Azure Stack HCI, but I also want to, tell the folks out there my experiences that I have with the product throughout my customer projects. And that's what we do here at Fast Track. We help customers, to take the fast lane to Azure, and Azure Stack HCI is a part of it. But now to you, over to you, Carsten. Who are
Yeah,
you?
my name is Carsten Rachval. I'm a Microsoft MVP, most valuable professional, in the Cloud and Data Center Management Group. And also in the Azure group. So fantastic. I'm the hybrid man, maybe, but my Twitter handle is Hyper-V Server, so maybe I have to change that. I'm doing, or my company is doing Azure Stack HCI, storage bases direct, and Hyper-V installations. And I'm from Germany, and Germany is the stretched country. So here everything is stretched, not everything, but I hear from many people that you stretch things in Germany where other countries don't think about stretching the stuff yet. So I have a lot of experience with stretched scenarios, and I've done multiple Azure Stack HCI stretched clusters in the last 2 years. And we want to share our experience, also the experience I made at customers, and the installation is most of the stuff how I prefer to do it. It's not all the Microsoft way. Bernard is a Microsoft way, but we will say what is in addition, what I do at customers to get more redundancy or whatever. So, but
Yeah.
before we dive into the stuff, we want
Mhm.
to talk a bit about what is a stretch cluster. Yeah.
Correct.
So, so this is my slide, Bernard. Why stretched clusters? And by the way, the photos that are used, the pictures that are used, are royalty free. They are from Pix, Pixabay or so.
Mhm.
Um, so nowadays, in many customer scenarios, the data in the VMs is very valuable to the business, even
Mhm.
if they lose minutes or they have to go back to restore from a backup. They lose a lot of time and also money in the company. So the data is very important. There are some companies out there, and they're getting more and more, who depend on the data nearly 24 by 7. And there are even some companies who are working 365 days a year. I have such customers where not
Mhm.
even one day in the year the production can be shut down because of different reasons.
Mhm.
So a stretch cluster can protect us against a local disaster. And now there are different kinds of local disaster. For example, in Germany, a local disaster would be a fire of a building. Yeah?
mm,
Normally, we don't have fire that spreads over large regions, or we don't have earthquakes here.
mm.
We don't have volcanoes in Germany, at least. In Europe, there are some.
Yeah.
And if you look at the US, for example, they have much larger disasters. So imagine we have these hurricanes in the hurricane season.
Mm,
Um, there it's not a good advice if you have two rooms on the same building, or two rooms at the same campus, and the hurricane hits. They are
yeah.
maybe both gone. Yeah. So
Mm.
the US has different, or there are regions on the earth where they have different catastrophes that we have, for example, in Europe. Europe is quite, so far as now, it's quite easy here. Yeah.
It's a safe place, but
It's a
you
safe
have
place. Yeah.
you. I mean, there are disasters could be everything like flooding. We do have flooding
Yeah, we
in
have.
Germany, but also I mean, we do have a lot of companies that are producing stuff, and they may have different subsidiaries, and there's a lot of construction work going on, and if you have someone digging into the road and crashing your internet cable, then that I
Or your
would call
power
also
cable.
as a disaster. So
Yeah.
this can happen here as well, right?
Yeah. So with the stretch cluster, we want to have multiple sites. In
Mhm,
the Azure Stack HCI stretch cluster scenarios, we're talking about two sites, not three sites or four, two
mhm,
sites. And if one of those sites is hit, and we talk about what a site is, we
mhm,
want our workloads to start immediately or nearly immediately on the other side. So if
mhm,
one site fails, could be a room, a building, whatever,
mhm.
we want our workload as soon as possible running on the other side, and the workload that is in the other side shouldn't be impacted. Yeah?
Mhm,
So we have like if a disaster hits or a power outage hits, we want our workload as soon as possible online again.
mhm,
Um, and there are some requirements where we have to use a stretched cluster in Germany, and I'm pretty sure in other countries there are also similar
mhm,
requirements. So, for example, if you have the financial sector, banks, and so on,
mhm,
they have to oblige search certain rules, and they have to stretch the data between data centers. I worked for some bank data centers, and they have to go over 10 kilometers between the sites.
mhm,
That's a requirement by a regulator. There
mhm,
are insurance companies, for example, they have the same requirements. And there is also critical infrastructure. So if you are producing something that is critical, for example, some foods or so, you have also to oblige those requirements, and you are required to not have all your eggs in one basket, meaning
mhm,
all your data in one room or all your data in one site. So you have to do a stretch cluster.
mhm.
So Bernard, some requirements for stretch cluster, and that's you, right?
Yes. So as for September 2023 with Azure Stack HCI 22H2, which is our current version at this time when we are recording that session, the technical requirements is a minimum of 4 nodes, right? So you need to have 2 nodes on each side in order to get that up and running. And as you are replicating the data from one side to the other, you need to have a high-speed network that is capable of, transporting or has enough bandwidth in order to transport everything that has been changing on one side to the other side, right? And vice versa. Um, and so, not a good idea to do it with a 1 gigabit adapter that is shared by other people as well,
No.
right? So, not a good idea. The other thing is you need to take care of the witness or where to place the witness as a third, sort of gatekeeper or quorum if you want to, because, and we'll talk about that later, it might not be a good idea to put the witness on either side or on one of the sites, right? So it needs to be an independent location. Yes, and most important, there's a caveat to this. As of September now, where we are doing this video series, which kind of features are supported on a stretch cluster? VMs that was Carsten was indicating or was showing that is supported. Software-defined networking. So in order to span a software-defined network over the two sites is currently not supported, right? The other thing, and that's maybe not so nice to hear for some of you folks, is Azure Kubernetes Services, AKS on HCI, is not supported on a stretched environment at the moment. That might change in the future, but as of today, it is not supported, right? So you cannot
Mm,
run a geo-redundant Kubernetes workload on HCI at this stage, right?
mm.
So, and
There are
if you're
some,
asking, yeah, let me just
yeah,
add, sorry for interrupting. And if
do.
you're asking yourself, how are you providing then the geo redundancy for AKS systems? That's what we say is rely on AKS itself and mechanisms that are within AKS or Kubernetes that can be used in order to, you know, um, distribute the workload from so that you have two clusters, one in one side and one in the other side, and then you are replicating
Mm,
your data in order to provide geo redundancy. But don't think it from an HCI perspective
yeah.
at this
And if
stage.
you hear somewhere that it's possible to do SDN and also AKS in a stretched cluster, of course, but the software-defined networking or
Mm,
AKS is not aware that it's stretched, and so it can't. AKS, for example, can't put the different workloads in different sites. So I'm pretty sure they're working on that, but in the moment, Bernard said it, September 2023,
mm,
it's not supported. And
mm.
let's go on. We have a lot of information to share. So we have two designs of a stretch cluster. So Bernard also already mentioned we have to have at least 4 nodes in our stretch cluster, two in each side, and we have a local pool of the devices that are in these two servers. And here we have the same, so we have two pools. And this scenario is the active passive scenario. So all our VMs are running on inside one, and they are writing and reading all the data of volumes, cluster shared volumes that are completely presented in this site on those two nodes, on the devices of those two nodes. But we want to have a stretch cluster, so we have storage replication, and we will talk about storage replication in a slide a bit later. And we replicate the volume here to the passive side, and all data that is written here is also on this side. So in the event of a catastrophe inside one, the cluster will switch over all the volumes, or the volumes will be brought online inside two, and the VMs will be started inside two. Bernard has an addition here. Bernard, please.
Yes. So, or maybe a question, right? It might be an obvious question, right? Is a stretch cluster scenario cheaper, or in terms
No,
of hardware requirements? No, obviously
no.
not, because you need to have the same amount of storage on the other side as well, right? And the same amount
Mm,
of compute in order to be able to run on the other side. I mean, it
yeah.
might sound obvious, right? But if you ever do a calculation for it, you need to multiply it by two.
Yeah. So you are completely right. We also want some redundancy on this side. So we will at least, our volumes here will at
Mm,
least have a two-way mirror, maybe even a four-way mirror. And if you have a four-way mirror here, you have also four-way mirror here. So the design of the volumes is the same. We would have 8 copies of the data. So
mm,
I've seen customers asking, isn't that too much? So let's do a two-way mirror for this volume. And then we have another 2 copies on this side. So this is already 4 copies that you
mm,
mentioned. It's doubled, but if you go for 4 copies on each side, you would have 8 copies. And you
mm.
have, of course, to think of that. And even the active passive scenario is more expensive because everything is running on these two servers. And these servers are only there if you have a disaster. So you don't use these servers for workload. And that is the perfect segue to the next scenario. That is the active-active design. So we have again a stretch cluster here, and you see the servers that are behind here, not perfectly aligned, but doesn't matter. So we have our 4-node stretch cluster, 2 in each side. But now we have workload inside one, and we have other workload inside two running, and we have our volume for the I think it's purple VMs. They have their volume here. They are reading and writing in that volume here, and it's storage. It uses storage replica to get all the data to the other side, and vice versa. Our red VMs have their volume here, and writing and reading data from this volume, and this is replicated to side one. So we can use the resources on both sides. That's a bit cheaper scenario because we have active workload on both sides. They are equal. We don't have an active and a passive side. We have both sides. And to add here, in Germany, what I've never seen an active passive scenario. All the customers where I implemented stretched
Mm.
clusters have an active active scenario. They want to use both both compute resources and storage resources. Doesn't matter, it's the same, but both or all four compute resources, or there could be even more resources. You will talk about that in a later slide. So they want to use all the compute resources for their active workload, usually the VMs, right?
So let me ask one question. I mean, stretching a volume is, you is optional, right? So I mean, nobody obliges
Mhm.
you in order to stretch a volume. So can you do a mixed kind of setup where you say, hey, I got some servers on site number one, which needs to be replicated to the other side, but not all of it. Can I do that?
You mean servers or VMs?
VMs, sorry. Yeah,
Yeah,
VMs, virtual
of course,
machine
you can
workload.
do that. Very good question, by the way, because many people think if it's a stretched cluster, everything is stretched. No,
Mm,
you can have, for example, imagine this is not here, the storage replica thing is not here. You have a local volume, for example, if you have, let's say, Exchange, and high available Exchange installation. I know Microsoft says every Exchange has to be in Office 365, but there are still customers out there that do their own exchange. How it's called? Um, DAG, I think. Is it DAG? Yeah, Exchange DAG. So you have
mm,
one or two Exchange servers in this volume, and the other Exchange servers here. And Exchange has its own replication mechanism. So
mm,
you would not put the Exchange here, use a replication to another volume, and then copy the volume also. So there is maybe workload that has redundancy in the workload itself, like SQL, Active Directory, Oracle databases. I think Postgres has the same SQL databases. Or you have VMs, let's say VDI. Yeah, we talked about in our AV Azure Virtual Desktop series on Azure Stack HCI. We have maybe many worker VMs where users can connect to. So if one fails, we have maybe 10 others, so he can connect to another one. Why
mm,
should I replicate this worker VDI VM where every application is installed, as in the other 9 is also all the same applications installed? It doesn't matter to which one the customer or the user connects. So why should I replicate those? Yeah. So as you said, we can have volumes that are only local to this site, and
mm,
also volumes that are only local to this site, and we put our workloads in there. And then we can have
mm.
stretched volumes where we have workload that has not these possibilities, for example. Yeah? You had
Yeah,
a question, Bernard.
yeah, maybe in addition to that. So I like the idea of what you put out, which is, if your application or your workload has its own geo-redundancy mechanism, then use that or consider at least it, right? Like Exchange, like SQL Server. I also do have customers that are replicating their SQL databases using HCI. However, I think it's still a very, very valid option to use SQL Server replication mechanisms like SQL Always On in order to do that. Um, and think of the geo-redundancy from the application level,
Yeah,
right? Um,
especially if we talk of September 2023,
right.
we have an additional cost for the replication, and it's maybe more than you think, and we will talk about that
Yep.
because this is not a marketing series. It's for people who want to implement the stuff, and there
Mhm.
are some things you maybe have to know before you implement them. So stay with us. We talk about
Yeah.
all the good things, the fantastic things, but also about the bad things. Yeah,
Right.
at least I'm here for that. Maybe Bernard, you
No,
don't
all good.
want to gamble with your job, right? So I do the bad things.
No, all good.
Okay,
I
let's
mean,
do let
yeah,
yeah,
yeah.
let's go
Go
to the
go ahead.
next
I
one.
mean, we
This
talked
is
to that point.
yours.
Yes.
So
So, what is, which options do you have at the moment? So, 4 node stretched, having 2 nodes on one side, two on the other side is supported, even 3 nodes. This would give you the option, in order, as far as I understood, to do a 3-way mirroring on
mhm,
each of the sites, right? 8 nodes are supported, but even more, as far as um, it's listed. However, I mean, I would not recommend to go for such big clusters anyway, but at least you can do it.
yeah.
Okay,
And you can't
next.
do 32 nodes now. We have still the 16 nodes that are for Azure
Yeah,
Stack HCI, but the 16 in total
mm,
are spread over the sides, right?
yeah,
So
that's a good. Yeah, it's a good add-on to this. So
yeah,
I think there was more to it, right? Which is not supported, like 2 nodes or 3 nodes, or using any odd numbers of nodes, which would give you, a non-equal count on either side. And I think
yeah.
it makes sense to do it.
It's
Or
important because
yeah.
sometimes people say, if you think of the active passive scenario,
Mhm.
yeah, you have one side that is where all the workloads are, and the passive scenario is
Ah,
only there if ever is there a failure. So
mm,
people think maybe let's put not as powerful machines there. Let's put less machines there.
mm,
Yeah, I heard that from customers. And to be really clear and upfront, an Azure Stack HCI scenario is really how you call it. It's the same number of nodes. It's the same devices. It's the same number of memory, same cores, and so on.
yeah,
You should do that. And I don't know if it's really a requirement with the CPUs, but I would not go another way because maybe you decide, no, I want to have an active cluster, right?
yeah. Yeah, the
Okay.
setup is delicate, and you will see it, right? So the last thing that I would recommend is to use a completely different or a hardware mix, right? So this is
Yeah.
not something that I would recommend at all. And
Good point. Yeah.
uh,
Yeah.
so go for it. Okay, next slide. I think that was you again, where you
Yeah. It
talk a
was
little
me
bit about,
again.
about the
Yeah. We talk a
failing.
bit about the witness
Mhm,
because we saw on the side before we have an equal number of nodes in each side. So
mhm,
it's always an even number of nodes. So if you have two on each side, we have four. If you have
mhm,
three on each side, we have six nodes in total,
mhm,
and so on. So the cluster has an even number of nodes. And if
mhm,
you have an even number of nodes, imagine here and that's really more possible in this scenario than in in any other scenario, like an Azure Stack HCI. We have maybe site one is maybe in, let's say, in Hallenberg, and site two is in Regensburg, where Bernard
mhm,
is stationed. Let's say,
mhm, mhm.
so we don't have many networks between them. We maybe go even over the internet somehow through a VPN or whatever. So there could be a network failure that these two sites can't see each other. Yeah. So and in this scenario, we would have two two votes here, two
Mhm.
votes here. So we don't have quorum. Let's say that we don't have a majority of nodes, so that the cluster can decide, oh, I'm the majority, I will run my VMs and maybe start the other VMs, and the other part is a minority, it will shut down the VMs and do nothing else. Yeah. So we have to have a witness in a stretched Azure Stack HCI scenario. So
Mhm.
now imagine we need an odd number of votes, and the witness gives us that. So we have an even number of nodes in the cluster, so we need another vote, and that's our witness. So we agreed we have to have a witness. So now the question is where to place it. And in this scenario, this is from you, lucky you, great. In this scenario, our witness is in side 1. So now
Mhm.
imagine, yeah, side 2 fails.
Mhm.
Okay. So before the failure, we have 5 votes. 1, 2, 3, 4, 5. So now the witness, the side 2 fails. So side 1 has a look. Yeah. I have 2 votes and I see the witness. Yeah, so I have 3 votes out of 5. I have a majority, right?
Mhm. Mhm.
Um, and I can start the VMs that fails because this is one cluster. Every
Mhm.
node has a copy of the cluster database and it knows what is running on the other nodes. So it knows server 3 and 4 has these VMs running. Yeah?
Mhm.
And it can start the VMs now because we have a copy of the data with the storage replication. We have exactly the data here. So it will
Mhm.
take this volume, bring it online. Before it was not online, but it was
Mhm.
there. Every write was there. It will bring it online, the copy of
Mhm.
the data, and then it can start the VMs.
Yeah.
Fantastic.
All
What
good.
we
Lucky
want.
you. Yes,
Lucky
that's how
us.
we.
So I do the bad part, and then you show us how to do it right. So
Mhm.
let's imagine not side 2 fails, side 1 fails.
Mhm.
So we don't have our 2 servers, server 1 and server 2, and our witness, it is placed in the same site.
Mhm.
Or even worse, it's placed on a VM that
Mhm.
is running on a server 1 or server 2. So it will fail also.
Mhm.
And now this side has to calculate again. It has one server, 2 servers, so 2 votes. It can't see the witness because it's gone, so it has 2 votes. But we had
Mhm.
5 votes, so
Mhm.
2 of 5 is not the majority. Our cluster
Mhm.
doesn't have quorum, so it is
Right.
a minority. So it will do something that people don't imagine. It will not start the VMs that are now failed. But even worse, it has a minority, so it has to
Yeah.
shut down its own VMs,
Mhm.
and we have
Ooh.
no workload running anymore
Mhm.
because this site is in the minority. You have a question, Bernhard, or
No,
a
no question.
remark?
Yeah, no, just an emphasizing, which is, might not be the expected behavior, right, of that cluster. But the witness is important, and that's why we need to place it right. And that's the next slide, right? So are you putting, or where should you put the witness in order to have a referee or a gatekeeper? And that's the reason why you need to put it in a third site, right? It could be an additional data center that has network connectivity to both ends,
Yeah,
or it could be, placed in Azure as a cloud witness. Um, and the reason is, in order to, let's play it through. So let's start again with site 1, I think, is failing. Site 2
of
fails,
course, it's
right?
side 2,
Um,
50-50, right?
yeah. Site 2 fails. What happens? Site 1 sees the witness. It has the majority of votes. It will start the VMs on its location, right? So all good. However, let's play the other way around. And I think it's also obvious, right? So if site 1 fails, site 2 on the right hand side can talk to the witness. It has the majority. It will prevent the previous case that Carsten was describing and start the VMs, right?
Yeah,
So all good. Um, it's also, again, not rocket science, but you need to consider it, right?
yeah. I want to add something because that the witness is not inside 1 or side 2 is if you talk with people about it, it's obvious. You understand it because if the witness is gone when that site fails, we explained it. But was also very important, and I will go back here to see it.
Mm,
We have to have independent connection to the other side. And of course, with Azure Stack HCI, I would I would take Azure and a cloud witness because we are connected to the cloud anyways.
mm,
Yeah, Azure is very redundant, what we have there. So, but most people don't get this. In many scenarios, side 2 is communicating to
mm,
side 3 over side 1. Yeah.
Yeah.
Or if you have Azure, not many people have independent connections to the internet on both sides. Often, especially in smaller installations, the internet connection is in one side, or they have only one, right? So if it's here inside one, you shouldn't do a stretched cluster at all, because if side one fails and your witness is gone, the cluster does something you don't expect. Everything is going down. So this is also an important part
Yeah.
here, the independent connection to your witness from both sides. Yeah.
And yes, you're right. Because if I reconsider, how many customers I talk to that have a central firewall or proxy where all of the traffic is passing through, especially the one with the internet traffic, then this is probably a thing that you need to test, right? Because
Yeah.
it's not only a failover for a site maintenance kind of thing, right? I mean, what you want to prevent is
Oops.
what you want to have is a geo-redundant solution, and therefore you need to test that it's really working in the direction. So the witness is very important in that scenario. Um, yes.
Let's
Yeah.
go to storage
Let's
replica.
let's go to the next one.
Yeah, and I pressed the arrow on. It was not to speed you up. It was just an arrow.
Yeah.
So so I do
So
the
how does the
synchronous.
yeah how does it work?
Yeah, we have two scenarios or two kinds of replication. That was the errors or the yeah the data is moved over the replication to the other sides, and we have two kinds of replication. We have the synchronous. Of
Mhm,
course, we want synchronous replication, and I will show you how it works. So we have a, let's say we have our application, our VM. Our VM is running here on the source side and is writing data, because reading data we don't really care. The data is not changed, so we don't have to get some change to the other side. Reading doesn't change anything. Only the
mhm,
writes change data. So our application, our VM, is writing something to our source node, and the source node is replicating the data over the replica network using SMB3. Very
mhm,
important. We use SMB3, very powerful protocol. We can do multi-channel, so we can leverage multiple connections to get to the other side. Um, we can't use RDMA. That's a requirement in Azure Stack HCI. We will talk about that in the networking part. So unfortunately, no RDMA, but still SMB3 is really powerful. Then
mhm,
we see here, we write at the same time the data at the same time where the data is replicated to the other side. We also write in a local log volume.
mhm,
Yeah? And on the destination side, as soon as the data arrives, it also is written to a log volume. So we have our data in the log volume on both sides. So now the data is on not in memory. It's really on non, yeah, it's there on devices. So if a power failure hits, our data is still on the side. So
mhm,
now the destination node acknowledge that the data is written,
mhm,
and the source node acknowledge the write to the application. And now the application knows, okay, my data is written. I can do another write or whatever. If that is done, now the data is copied from the log file to the data volume. Yeah.
mhm,
On this side, the data volume is online, and on this side, it's not online. We can't change the data volume here. There is only read only if you want to, but usually it's also not read only. And here you can read and write. Yeah.
mhm,
So you see, we write on both sides. When the data is on both sides written in devices, we get the acknowledgement and we know the data is on both sides. So it's
mhm,
synchronous. Every
mhm,
day, every write is done on both sides when the application gets yes, your data is written. We have some requirements, of course. The network latency between the two sides should be low or very low. And maybe you have a
What is what
question.
is what is what is very low? What is
So
very?
in latency in devices, in storage devices, we usually talk about milliseconds or even sub-milliseconds. So if you look at an NVMe, for
Mm,
example, and we see many NVMe installations, we have maybe a latency below zero point 0.1 milliseconds or maybe zero point 0.2 milliseconds. So 200 microseconds. If you imagine here, the source is in Hallenberg and the destination would be in Regensburg, that is even 300, 400 kilometers over the air. So usually it's not as fast as writing an NVMe. We would have maybe 3, 4, 5 milliseconds already here, or
yeah.
even
Mm,
10. So
mm,
every write of the application, in addition to writing it to the volume that has already some latency, we add to every write the round trip time and the write here.
mm,
So if this is, for example, 1 millisecond to write the data here, we add another millisecond to write the data here. Yeah.
mhm,
And then the round trip time. So for Regensburg, maybe it's 4, 5, 6, 7 milliseconds. So our application slows down because of the synchronous replication. So we need low latency, or we have to do the other replication that will you explain very soon.
mm,
And of course, the log volumes here have to be flash, because
mm,
if that would be hard disk, and nowadays
mm,
hard
mm,
disk, if you need performance and if you do a stretch cluster and you don't need hundreds of terabyte usable space, go with flash devices. So you would have already flash devices also for the data, but the log file must be on flash. The data should be on flash. Yeah.
mm.
So, and we have nowadays, what I've seen in all my implementations, the writing to the log, the source log file, takes its time. It's how it's implemented. So I see usually here a 3 millisecond
Mm.
delay while writing to the log file. This is the
And I
source
think,
log
yeah,
file, not
so
this one. This one.
yeah,
Yeah.
so two things, right? Which let me emphasize this. So the network between the two sites is the critical piece, right? We can't go faster than the latency on this
Yeah.
network,
Yeah.
right?
It's
Um,
speed of light or whatever.
right. And also the devices that are in between, right? Because we
Mhm.
will see later that you need routers for that, and routing costs time. I mean, you
Mhm.
need to inspect the package and whatnot. Second thing, step number two is costing time. So there's a time penalty to this, and we will see that even if the network between the two sites would be very thin, very short, and very fast, you would still see that there is a performance penalty to this
Yeah.
because of the way how the log file is currently implemented in 22H2. This is about to change in order to get more performant, but as of now, this is the current state.
Yeah.
But we'll
So
approve it and see it and how the
yeah.
behavior goes. Right.
So I've never seen it faster than 3 milliseconds,
Mhm.
the whole part here, or this whole part, even if they are
Yep.
the source and destination are very near together. We will talk about that. So if your application is killed with 3 millisecond latency, this
Mm,
is not for you, at least not in September 2023. Yeah,
mm,
you have to consider that. Yeah? And there's maybe you talked about SQL Server. The
mm,
way SQL Server does is always on magic. This is, of course, not depending on that. So, for
mm,
example, if you need a high performance SQL Server, that's maybe not what you want to do or should
mhm,
do. Yeah? But let's talk about the other way, because
mhm.
usual people think, okay,
Yeah.
synchronous replication is too slow for me. Let's do the other thing. And now you explain, please, the asynchronous one.
Yes, so starting again with the two sites, right? So the first step is the application is writing a block in the source system. The first thing that happens is it will be written into the log file, like before, right? However, the next thing is a little is different from the previous behavior. The acknowledgement will be, as soon as the data is written to the log file, it will be acknowledged back to the application. Application is fine and can go ahead, right? Then we replicate over the block using SMB to the other site, and then we will write into the log file again, and then the acknowledgement comes back, and then at some time later, the data is written to, or the block is written to the data volume on both sides, right? However, I mean, that's seems to be faster, right? Still, we need to, for the log volume, it is important. We need to have it on flash, but there is still a notable performance penalty to this, right? Because step number 2 is the one that takes some time, the 3 milliseconds that Carsten was explaining. You will see it here as well, right? So although you do asynchronous, it's not, in some scenario, it's not, it can't be faster than how fast we can write to the log file,
Yeah.
right? And also the same mechanism applies here. It will also is subject to change to get more performant in the next version. So stay tuned if you really need this, but be aware that there is a performance penalty to this.
Or at least Microsoft is aware of that problem and
Mm,
they are working on it. But if it's in the next version or the version after that, we will see. Yeah,
mhm.
we don't really know as of now, but they
And to
are
make
aware.
yeah,
Yeah.
and to make the people interested in what's coming on this session, right? I think we are going to show how much it will be, right? Or
Yeah, of course, we will show that. We will not just talk about it, but to be fair, if you
yeah.
have a geo-redundant cluster, yeah, maybe asynchronous replication brings you an advantage because in the
Mm,
moment this will be fixed with a log file. I'm pretty sure of it. When depends, but here, if you go 1,000 kilometers
mm,
or 1,000 miles between the sites, you will have a noticeable latency because of the network. So going asynchronous, the application writes the data to the log and then you get the egg. That's very fast. It's even faster than it's much faster than the synchronous. Yeah.
mm.
So
Yeah.
if your sites are too apart of each other, maybe asynchronous application is for you. And
Yeah.
of course, you don't have the guarantee that the same data is on both sides if the source side fails, but this replication is continuously. So it's not every 5 minutes or every 15 minutes like Hyper-V replica. It's just a little bit behind. So maybe it's a second behind or 50 milliseconds or 5 seconds. But you
Mhm.
have still a very a copy that is very
Yeah.
is not very different to your original data. So
And I would,
better to have a copy that is very near
yeah.
to your original data than restoring a backup that is maybe 6 or 8 hours old or even older, right?
And think of it. I mean, you still might have a 10 gigabit lane between those two sites, which might be operated by someone else, not by you. And if you experience some outages at some points, right, where you say, maybe I'm not trusting it fully to be 100% online, right, then this might also be a good candidate for you, because if you see some glitches in the network, right, what you don't want to have is to wait for the network in order to come back and tell you
Mhm.
to the application to finally acknowledge it, right? So you want to go ahead, and probably for that would be a scenario to be used more often.
Yeah.
Okay.
To not get over the hour with the
Yeah.
first video, we are already at 43 minutes.
Mm,
I got to the next slide, and we have two scenarios or two extremes, let's say, how we
mhm,
can do a stretch cluster. Yeah. This is a slide from a Microsoft presentation, and in this slide, you see we have a 4-node cluster. That's the minimum. It's stretched over two sides, and to be clear, one
mhm,
part is in London and one is in Paris. So this is one extreme where
mhm,
you're not even on the same continent. Yeah, it's the same continent because London is on an island called Great Britain, right? And Paris is in France, and it's on the European main continent. I hope this is politically correct. I don't know it exactly, but um, um, London is on an island, right?
yeah.
So we have even water between those. And to be clear, this Bernard. So these are roughly over the air 420 kilometers. So, but in miles, it would be around 300 miles, I guess, maybe, yeah, 300 miles, maybe 280 miles, still a huge distance in Europe. And this would be through the air. So normally, if you go, you don't go over the air. If you want to communicate from London to Paris, you will follow some cable. So that this is even longer, and you have a latency here. So the data has to travel, let's say, 1,000 kilometers, and that's already noticeable with the speed of light. We usually are connected over a wide area network. Not many customers have enough money to get it or to even install a direct line between Paris, or a direct cable between Paris and London. Maybe there
Mhm.
are some. There are stock exchanges. Maybe they have these kind of direct lines, but the usual customer wouldn't. And of course, if you are in London in a data center and in Paris, it's not unusual that you have different IP ranges for all your things in the data center, the networks we need, and even maybe for your workloads, because the firewalls in London have a different, you have different internet connections here than here, and you use
Mhm.
different IPs here and here because the data has to come to you. Yeah, so this is one extreme where we have a very or a far separated geo redundant cluster, or even a country redundant cluster. And now we have the other one that is Bernard talking about, right?
Yeah. So, okay, what we usually see, I mean, and it might be because we are uh, don't have these kind of customers, but what we usually see is a much smaller scenario where the geo redundancy is sort of wanted to be reached on the same campus, or maybe on two campuses that are less than 200 meters apart, right? So maybe you have two different buildings where you put your hardware into in order to be protected against some fires or something like that, or you want to be protected for power or internet cable connectivity outages or something like that, right? So most of the time, the people are interested in uh, stretching, but not so far apart, right? So they have their dedicated switches environment. They have, they control the sites, they control the network, and maybe they also, or most of the times stretch the VLAN on that system, right? So they even share at some point in time even the same IP address ranges, right? Or that's most of the times happening. So that's a little bit more the common scenario. So
Yeah.
that I would
To give
say, right?
numbers to that, more than 80% of the stretch cluster scenarios I have done in Germany are around this. Some maybe 50 meters, some 100 meters between the rooms, the sites. Even some customers have containers for your service and so on. But I also have done a scenario that is over 10 kilometers, and even a scenario that
Mm.
is over 50 kilometers. There are there, but usually, at least what we do, or what's considered a stretch cluster in Germany, is below 1 kilometer, and it's all
Mhm.
the customer controls the whole environment. Let's say it
Mhm.
that way. And you
Yeah.
put it at stretched VLANs. We have the same IP addresses, same VLANs in both rooms, or both buildings. Yeah, so we can do layer 2 between the sites, yeah, and not layer 3. If we go over a wide area network, we usually do routing, and we need layer 3. Yeah.
Mhm.
So let's do the next slide.
Which is
These are
your grouping, right? So it might
yeah.
be before we conclude the session here to do some definitions on
Yeah.
what a stretch cluster could look like.
So because I'm not really, so we have both extremes. Let's
Mhm.
say we have a 420 kilometer cluster, or even a larger one, and we have a very narrow one. So I would call the larger ones metro cluster, for we have different cities, or even more. It's a large stretch cluster, or the distance between the two sites has a certain amount of kilometers or miles, usually over maybe 10 or even over 5, we are talking about several, sometimes hundreds of kilometers slash miles. The network between the sites is most of the time a WAN. So the customer doesn't have a dedicated, uh, it's not their own network, or they have dedicated fiber between that. That's also possible, but um, uh, it's a WAN. Not We don't have many redundant network paths between the um, between the sites. So usually, if you go through a WAN, you maybe have one, maybe have two different ways to get from one side to the other. And if it's really far away, we maybe have different IP ranges for the workloads. And so in one side, you have a different IP range and router and DHCP servers, and in the other side. And that's, of course, you have to think about when I have a failover of a VM to the other side. Now it has to use another IP address. How to do that? So that's a completely other level. And then we have the I call it campus stretched cluster, because campus, like, on the same area of a company, for example. So
Mhm.
campus, we have two sides, they're on the same campus, some meters apart,
Mhm.
between maybe 50 and 800 meters. Maybe
Mhm.
even you have a customer who has two rooms that are separated by a firewall. And this time I don't mean a router that is inspecting the IP packets. It's a wall that can withstand a fire. So you have two different rooms where one can burn and the other not. And then you
Mhm.
maybe have only 20 meters or 10 meters. Yeah? The networks between the sites are high-speed LANs, and we are talking 10 gigabits or more, 25, 50, 100, multiple 100 megabits. And we have often dedicated switches for our communication between the sites. So we have multiple ways. We have our core infrastructure that connects both sites, and even maybe dedicated storage switches for replication and our local storage. And we have
Mhm.
plenty of redundant network paths because we own the network. We can do multiple VLANs for the different traffics. And of course, our workload has the same IP address in both sides. So if it's running in one side or the other side, it doesn't matter. It's the same routers, the same DHCP service, the same DNS service, whatever you have, the same AD controllers, and so on. So this is a very large scenario, and this
Mhm.
is the narrow scenario. And I have to say, this scenario is the most used scenario in at least Germany. Maybe in the US, this is the most used scenario, but in Germany, we have this a lot. And I talk to other people in other countries, even in Great Britain or Austria, Switzerland,
Mhm.
whatever. You have often this campus stretch cluster.
Mhm.
Okay. Um, and to be really clear, as of September 2023, for both stretch cluster scenarios, the narrow one and the very large one, the only supported Microsoft solution is the Azure Stack HCI stretch cluster that we show in this series. There are other ways how to separate workloads, how to separate Azure Stack HCI nodes, how to separate storage spaces direct nodes even. These are not supported by Microsoft. Yeah?
At the
It
moment.
doesn't mean it doesn't work, but it's not supported. And that's very important. If you call Microsoft support with a problem in your stretch cluster, you have to have an Azure Stack HCI cluster with two pools and with storage replica between the sides to have a supported scenario.
Mhm.
Bernard, you want to
Yeah.
add something to that?
Yeah. This is, the status from September 2023. It might change, but it might not change, right? So stay tuned. But as of now, this is something that you, when watching the series, need to check independently, right? Because at this time, what Carsten said is correct. HCI stretch cluster is the only answer to both of these scenarios, right? At the moment.
So I think
But
this was the longest video in the whole series with
yeah,
55 minutes. So
yeah.
in the next video, we talk about the network and what you have to install before. So I hope we see
Yes.
you still there, and
Yeah. Yeah.
this is also important, right?
Let me add a little bit to that. So we are not starting from scratch with everything, right? So we did a 23 videos on installing HCI. We are reusing or some parts of it. That doesn't mean we are copying it. We're just forwarding you to watch this series if you wonder how to get the operating system installed on the nodes. Our case would be, the OS is installed, they are domain joined, but we tell you how the networking looks like, and that's part of the next video. So be aware that there is more to more stuff for more content laying around that you need to reference. Okay.
Okay.
So
See
I
you on
would
the next
say
one.
see you in the next one for the networking.